For those of you guys just joining us, they were working in the back of their homework spirals on these two problems. I did have a hint on this tricky one. That one was pretty straightforward with L'Hôpital's, but we're quickly going over some logistics. I am getting homework solutions ready to go. However, in your Google Classroom, I did, I think, add yesterday that was posted this morning, the review, or did I already post the review? That's not Classroom. Wrong one. Where's Classroom? Okay, well, it disappeared. Sorry, guys. Shoop. As we do that, let's go ahead and get logged into our book in case you guys have any questions. L'Hôpital's can be sometimes super high, straightforward. Good morning. However, L'Hôpital's can also be a bit tricky. So in your guys' classroom, we already mentioned just a second ago, that's really zoomed in. Something's weird. The design ideas we'll talk about a little bit later. We have some comments on there. But, oh dear, where's your guys' review? It hasn't shown up yet, huh? All right, let's go ahead and get that review in. Guys, in your homework spirals, why don't you turn really quickly to that next blank page after the review. Let's go ahead and write down our test review because today there might be a bit of time for a work day. Usually we have like a whole in-between day where the review can be due, and then we go over questions to the review. And then the practice test is due the next day. This is not occurring this time though. This time it's just like pre-cal. It's an old-fashioned review due the day of. We might go over a few questions before because the quest is not as long as a normal test. Let's see, do I have the actual review in here? No, I don't. E for effort, but there's our L'Hôpital's. I'll be able to get it over here. So that is going to be a little weird for you guys in that we don't have a practice test, but we'll try to practice as much today as possible. Let's recap really quickly what the quest on Monday is about. So what was section 3.6? Reminders. Oh, you guys are going to see it now. What was section 3.6? What does optimization mean? Max and min. Oh, it's because it wasn't on there. Yeah, max and min problems, right? Critical numbers. We have to find our primary, our secondary. What's differentials? Wait, it wasn't just differentials. What else was in this section? Wasn't it also, why am I putting linear approximation? What's linear approximation? Using a tangent line. Good. So we do y minus f of c equals f prime of c times x minus c. And how do we use it? We plug into it. And then we have L'Hôpital's. And what is L'Hôpital's helpful for, guys? Limits. But what kinds of limits? Limits that produce indeterminates. Now, what are the easy indeterminates? As we saw in this example right here. Okay, or did anybody from homework see the other easy type? Not just 0 over 0, but also infinity over infinity. You don't just have to use degree tests. We can also use L'Hôpital's. And we're going to grade that homework and see how you guys did and see any tricky ones along the way in just a second. Since the review, isn't in that homework sheet. Wow, I don't know where it disappeared to. Let's get back to our homework spiral problems. Sorry to make you flip back and forth, but let's get back there and we'll come back to the review in just 1 second. All right, cool kids. As the ebook comes up, you should have plugged into this guy. And I know, I'm not making a big deal about notation, although I'm kind of trying to broaden our horizons just a little bit. We're doing an arrow and not an equals. What happened when you plugged in? Because 3 times 0 is just 0, right? And sine of 0, which we need to know our unit circle, is also 0. So yes, we get 0 over 0 is what this would produce. We call that indeterminate. Technically, we would have to, if we had some more time and we needed to like fully justify our solution, talk about how both f and g are differential equations, which they are. His derivative exists everywhere. His derivative exists everywhere. Now, the projector's going out. Go team. What are we allowed to do then from L'Hôpital's? Yeah, derive the top and the bottom. However, can you guys look at your work? Did you rewrite the limit? If not, I'm taking off points. Check it, check it, check it. Rewrite your limit in a colored pen. Remind yourselves. What was the derivative of the top? What was the derivative of the bottom? So why am I putting an equals and not an arrow? Because what happens when I plug in? 3 minus cosine of 0 all over 1. And what's cosine of 0? So what was your final answer? You got there, yeah? But why was this one harder? What happened when you tried to plug in? Now technically to make this one legal, to be honest right now this would not exist because can I come from below 0 in a square root? No, that'd be... Can I come from below 0 in an ln? No, there's nothing over there. So really quickly, I need you guys to make this problem legal. You would not be needing to make the problem legal. I would need to give you legal problems on the quest or on any sort of homework or quiz or test. Okay, now the problem's legal. So if we plug in from above, that's legal, and plugging in from above, that's illegal. But hold on, square root of 0 is 0. But what's ln of 0? Doesn't that not exist? But what kind of not exist? I just showed you the graph. Negative infinity, good, right? 0 times negative infinity. Wait a minute, pause. Can I say that's 0? Can I say that's infinity? Or can I say that's indeterminate? Do you guys have a forever card that you need to study? Yeah. It's only one for 3, 6, 3, 7, and 7, 7. It's only one. But we need to make sure that when we see 0 times infinity, we don't just say it's 0, which it could be, or infinity, which it could be, but we can't. Remember, we can give little answers. Where's that page? We can give little answers for these guys. 0 to the infinity, we can say approaches 0. 0 to the negative infinity, we can say 1 over 0 approaches infinity. But what we can't say is 0 times infinity. That's indeterminate. But here's the struggle. Is it one of my nice forms? So I don't have an f over a g? So I can't use L'Hopital's? Did you guys hear me? You can't use L'Hopital's right now. All you know right now is that this is indeterminate. Now technically for my little trick, my idea about if division by a fraction is multiplication by the reciprocal, then multiplication by a fraction, I told you guys to put it over 1 before we started the video. Multiplication by a fraction is division by the reciprocal. We'll see that in a second, but first of all, is this guy differentiable? If we go taking the derivative, aren't we going to have to use product rule? And wouldn't product rule get me 1 over x's and 1 over square root of x's with like addition? Wait, no, that's not differentiable. That's not going to exist at 0. Wait, what did my forever card say about that differentiability thing? Such that f and g are functions that are differentiable everywhere except possibly, who's c? Yeah, in this case it's 0. So it's actually okay. It still meets the condition because those functions are going to be differentiable everywhere but 0. And that is allowed for in L'Hopital. So we're actually okay on this one. Even though the derivative would not exist at 0, it doesn't actually have to exist at 0 for my condition. So we can say differentiable for all x not equal to 0. That's okay. That's allowed. So we have this condition being met. We have an indeterminate form being met. So what do? Rewrite. Because I cannot, as we just talked about, I cannot use L'Hopital's unless I have an f and a g. And now I do. Is that true? Is the square root of x times ln of x the same thing as ln of x over 1 over square root of x? Yep. Multiplication by a fraction is division by its reciprocal because division by a fraction is multiplication by its reciprocal. Do you see what I did? Guess what you can almost always do when you have an indeterminate form with multiply? Figure out which guy would be easier to flip and divide by. And maybe that makes a little bit of homework more possible than it was last night. Because now what happens when you plug in? ln of 0 from above, we already said, Ryan said, was negative infinity. And the limit as x goes to 0 from above 1 over square root of x, you might be like, well, that's gross. Well, you know 1 over x. And 1 over square root of x is always positive, so it's actually just going to be this one. That's going to be a positive infinity. Hey, what can we do? L'Hopital's. The negative is just kind of something off to the side. I really have an infinity over infinity, maybe with a negative in front. Either way, I don't know what that is. Maybe the bottom wins. Maybe he's stronger, so that's going to be 0. Maybe he's stronger, so that's going to be infinity. Maybe they're tied. I doubt it. How do we know for sure? L'Hôpital. So help me out, cool kids. L'Hôpital says what? Derive the top and you get? Real quick, just reminders. He's F and he's G, right? So we're doing F prime on top for L'Hôpitals, and we're doing G prime on bottom for L'Hôpitals? Okay. So who's the derivative of ln of x? There you are. And who's the derivative of... do you love yourself? Rewrite it. What's 1 over square root of x the same thing as? X to the... So much easier, right? Okay, bring down the negative 1/2. Careful. Don't get lazy. Don't just go to what your brain thinks. What's negative 1/2 minus 1? Minus 2 over 2. Good. Negative 3 over 2. Times u prime. U prime of x. Just... Ugh. Plug in. Guess what? We get 1 over 0 and 1 over lots of yucky stuff with 0. Infinity over infinity. Still L'Hôpitals. But what haven't you thought to do? Don't just keep going with L'Hôpitals. Always try to simplify, because maybe it'll make it legal or possible. How do I simplify? Do you love yourself? Please rewrite. So I'm going to get 1 over x all over negative 1 over 2. Isn't this x to the 1/2? Now, some of my little slanty fractions are going to confuse a few of you in just a second. Let me actually make them nice and pretty and obvious. Negative 1 over 2. Isn't x to the negative, okay, so it's down the little baby part of the fraction, 3/2, isn't that 1/2? Does it make sense? I'm going to do this and this, right? Don't stop rewriting your limit. What's division by a fraction? Multiplication by a reciprocal, so can't I say this is the limit as x approaches 0 positive of negative 1 over x times 2x square root of x all over negative 1. Now what? The negatives reduce. The x's reduce. What am I left with? The limit as x approaches 0 positive of. Now here's something else a few of you guys got a little confused on. Or you might have gotten confused on. How do I plug in a 0 positive? 0.1? 0.01? 0.001? I don't know their square roots. As long as you're dealing with a continuous function. As long as you're dealing with the continuous function, the value at c will be the same thing, because continuous, they have to match up. The value at c will be the same thing as just plugging in. Whether you're coming from above, the limit as you come from above will be the same thing as just plugging in at, which would be at 0. So our final answer, Patricia, I'm coming right back, is going to be 2 times 0, which is 0. Go ahead. Because I magically started writing a negative. Good question, kid. Did anybody else see that? Derivative of ln is just a positive 1 over x, and for some reason, I don't know what I saw. I think I saw him and I stole him. So hold on, he still has his negative 1. That's just my normal. That guy cancels. The negative is stuck. So that's a negative. But lucky for me, ha ha ha, it's still 0. That was close. Janelle.
So it kind of says like limit as x approaches 0 from above, like it's going to be or
it could still be 0 over 0. Just in this case, I had number over 0, which vertical asymptote is infinite form, something infinite. And then ln of, I thought about my graph, negative infinity. So this one, just because of who we had, ended up being infinity over infinity. But let's say I had something like the limit as x goes to 0 of square root of x all over, well, this one's going to be too easy, sine of x. There you go. It could be from above, because it would need to still be just above, because if it was 0, it would not exist. So it'd still be above, but it'd still be 0 over 0. Does that make sense? Yeah, just depends on who you're given and what happens when you plug in. That's something, though, some of you guys, a blast from your past that you kept on seeing, or you're going to keep on seeing a bit. Quick reminder, when you get number over 0, that's not indeterminate. Do you remember what we said? Number over 0 approaches. Didn't we always write plus or minus infinity? Check the sign. Ooh, okay. So number over infinity, that's the reason why over here, when I had ln of approaching 0 and 1 over square root of approaching 0, this one was from the graph, negative infinity, and this one was from the idea of, oh, plus or minus infinity, check the sign. If you check the sign, positive 0.1, positive 0.01, all positive numbers. Hence why I did positive infinity on the bottom and on the top. Sorry, that kind of got stuck in there, but negative infinity for ln just because of the nature of the curve. Sometimes I say things like, oh, number over 0, you guys should know that. And you should. But maybe it's kind of nice for me every now and then to be like, remember that was a thing. Okay, so we went over what happens if you get a nasty 0 times infinity. You guys showed me for the most part, just by the majority of you being like, yeah, it was easy, that you get the main idea of L'Hopital's. And we saw yesterday, okay, sometimes it's a little bit nasty because you have to do L'Hopital's. Well, he was kind of basic. But this one, didn't we have to do it over and over again? But remember, you stop doing L'Hopital's as soon as you stop getting an... There you are, indeterminate form, right? Stop doing L'Hopital's as soon as you stop getting an indeterminate form. Now, speaking of indeterminate forms, let's get back to our notes for a second, because yesterday on the video that you guys were supposed to check out if you needed it was this example. And if you watched the video, you would have seen somehow this ends up being E. And at the end of the video, I mentioned something to the effect of, and I know I'm sorry, people were randomly walking in and being like, are you taping? Anyway, it's okay. They were cute. I did say something about the end of the video. You could just memorize this guy. You could actually kind of add him into the bottom of the L'Hopital's card. But that's not going to necessarily help you on all the different times you see this idea. I'm still going to show you the idea of how to solve him, but some of you might want to write as a little note at the end of your L'Hopital's card that the limit as x goes to infinity of 1 plus n over x to the x will always equal e to the n. It could save you some time if you ever see it. The nasty thing is if they were to put this on the AP, it could just be multiple choice, but it could be a long answer, and they might not be happy if you just go straight to the e to the n. But that's one of the reasons I don't think they would ever show this on the AP, because it technically is a limit that a lot of, especially BC kids, just memorize. So if you did memorize this special limit, oh, you could also add it to the special limit card, although we didn't know L'Hopital's way back when. What else was on the special limit card? It was like, what, the third forever card? The limit as x goes to 0 of sine of x over x equals 1. Or the limit as x goes to 0 of 1 minus cosine of x over x equals 0. You could add this guy in there if you want. If we didn't already. One year I think I actually did add it into that card early on. So if you had that memorized, you could look at this and be like, oh, it's 1 plus what over x? 1 over x to the x. Guess what? It's e to the 1. Yay, we're done. But why? L'Hopital's. Why? There is a formula, and you could just go straight to e to the 1, aka just e. But why? L'Hopital's. I'm going to go really, really, really fast, and if you want to hear more explanation, go check out the video that you should have already checked out. But my explanation right now wouldn't have helped you in homework. If you were to try to plug in, you would get 1 plus 1 over infinity to the infinity. Now hold on. If I have 1 over infinity, maybe something else you guys were struggling with last night. Who wins, top or bottom? No, not even close. Who wins top or bottom? If you can't tell there, tell here. Who wins, the 1 or the x? Bottom wins. Why? The degree of this is 0, the degree of that is 1. But guys, you know 1 over x's graph, as you go to infinity, doesn't it have a horizontal asymptote of 0? Or, which number is going to be bigger? 1 or 5, 10, 100, a million, 10 million, 100,000 million? Who's bigger? Bottom. What happens whenever the bottom wins? Yeah. So I can say this is the same thing as 1 plus 0 to the infinity. But what is that? Indeterminate, right? So if that's indeterminate, L'Hopital's. But I can't. I need an f over a g. But we can't get an f over a g. We can get a common denominator. If you watch the video, you'll see me do that. X plus 1 over x. And I'm like, yay, let's go. No, the x is still stuck. So instead, we have to think about something that we had to think about that some of you are still struggling a little bit, but you should have at least grappled with a bit more with your Chapter 2b corrections. How do we take the derivative of something like, 5x to the x power? Can we use x to the n? I don't even need that. I could just put that if you want. Well, here. What was on the test? I don't even remember. Oh, well, something like that. Okay. Can we use x to the n? Can we use b to the u? Nope, not a b. X to the n, that's a constant. B to the u, that's a constant. Neither one. Do you remember what we did? ln both sides. Why? What can you do when you put ln on both sides? Pre-cal says there's a property of logarithms that power comes down. We're going to do that just with this guy. We're going to do that just with this guy. So I'm going to say y is equal to 1 plus 1 over x to the x. That's the function whose limit I'm trying to find. So our goal the entire time is to find the limit as x goes to infinity of y. Okay. I need to remind us of that over here off to the side because this is going to start looking different because I'm going to bring in an ln. Now here's what's weird. When I bring in an ln and I take it at both sides, there is a property of limits, and this is back from limits, back when we first covered them at the very beginning of the year, that says with a limit, if you have f of a limit of g, it's the same thing as the limit of f of g, depending on the continuity and differentiability of the function as x is approaching your constant. Without going too deep into that, it's kind of cool because we can actually bring this ln inside the same way that sometimes we brought it outside. So we could say this is the same thing as the limit as x approaches infinity of ln of 1 plus 1 over x, which is nice because what can I do with the x if the ln's on the inside? I can bring it down. And then, well, some of you are like, everything's better, right? But if you go to plug in, don't you now have infinity times 1 over infinity is going to 0, bottom wins, 1 plus 0 is 1, ln of 1 is 0. After all that work, I still get a nasty indeterminate, and the answer is yes. But what did you just see me do if we had a multiplication indeterminate? Divide by the reciprocal. So make the x an x over 1, and then you can go ahead and say, I'm not going to flip that ln. No, thank you. I love myself, remember? For better or worse. So ln of 1 plus 1 over x divided by 1 over x. Now what do I get? If I plug in infinity, ln of 1 is 0, and if I plug in infinity, what's a number over infinity again? What happens if the bottom wins again? Approaching 0. Now I have an indeterminate, but what kind? The kind I like. So now what do we do, guys? Derive the top, derive the bottom. Now some of you might want to think about 1 over x as being x to the negative 1. Makes it a little bit easier. Bring down the negative 1, x to the negative 2. How do I derive ln of something? ln of u? U times u prime. Good. So 1 over no. Yes. You guys spaz yourselves out too much. Make things stressful that don't need to be. 1 over u, whatever. Just 1 over him. Just write him. Whatever. We'll figure it out. 1 over u times u prime. Well, what's the derivative of 1? 0. What's the derivative? We just did him. It's going to be the same thing? What can I do? Cancel it out. Now what? What happens if you plug in infinity? Bottom wins. What happens when bottom wins? That part goes to 0. So I can go ahead and say that's going to approach 1 over 1 plus 0. Oh, I'm done. 1. No. Who's been chilling over here the whole time? ln of the limit as x goes to infinity of y. Who am I actually trying to find? So how do I get to him? Not divide. I wish I could divide by ln, but it's ln of. How do I undo? Inverse. What's the inverse of ln? No. Ah. I need e to the power of. Done. Dun, 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 dun. E undoes ln. Limit as x goes to infinity of y, which is the limit as x goes to infinity of who y was, is equal to e to the 1, which is just e. With that, kiddos, let's go ahead and go grade 7-7. With that, let's go ahead and go grade 7-7. I have 6 and 16 and 32 up on the screen. I think we only have like one more after those. Let me give you a second. Number 6 was in that very, very beginning section. Well, there was a little bit, but one of those early sections where it said solve 2 ways, because this one's a polynomial 0 over 0. You could have just factored and plugged in. That's the old school way, but now that you know derivatives, which is why the BCers wanted to use L'Hopital's on everything that you guys had to work with algebraically, you could just take the derivative and say 4x plus 13 all over 1. Plug it in, done. Do some of you like factoring better? Okay, then you're going to do that on the AP. Hopefully you remember it. Are some of you guys going to love L'Hopital's and use him as much as possible? Okay, then do that as well. But did the answers end up being the same? Yes. Either way, you get -3. That section was just to have you practice both ways and kind of choose a way that you like better. But eventually, you got to problems where it was like, this. There's no way to do this the old-fashioned way. There's no way. You can bring down the 3, but you can't factor the ln to cancel out. I mean, x plus 1, x minus 1 doesn't reduce with ln. But what you can do is you can take the derivative. Now, some of you would have done the derivative of ln of u to be 1 over u times u prime, 1 over x cubed times 3x squared. It's still 3 over x. It's the same as if you put down 3 and then took the derivative. Both ways work. Both ways work. Number 32, they talk about something called the squeeze theorem, which makes it a little bit messy. Here's the struggle. If you guys had used L'Hopital's for number 32, wouldn't you have gotten an answer of 1? Did anybody get 1 for number 32? L'Hopital's says 1, so how on earth can the answer be 0? What logic, conceptual mistake did those of you guys make who tried to do L'Hopital's? What happens when you plug in? What's going on as you go to infinity of sine? And as you go to infinity of x minus pi. Yes, this guy does go to infinity. I totally agree. But what does this guy do? Where are sine's y values going? Even as you go forever, forever, forever to the right, where is y's going? 1 to negative 1. Is he going to infinity? No. Negative infinity? No. To a number? No. He's stuck. Well, he's lame. He's just going to keep on oscillating. Here's my question. Who's stronger then? Top or bottom? Say it louder. You're right. Bottom. Oh, bottom wins? The answer is just 0? Guess what? This wasn't infinity over infinity, so L'Hopital's didn't apply. So just because a limit, in a color pen, you better make a note, just because a limit is messy does not mean L'Hopital's. We can only use, and Janelle, this is kind of like what you and I were talking about, when to use L'Hopital's. Just because it's messy does not mean it's L'Hopital's. Sadly, I wish it did. Just because it's messy does not mean L'Hopital's, because, number one, the function has to be differentiable. Or I should say f and g need to be differentiable. And these guys are. Their derivatives are fine. Derivative of x minus pi is 1. Derivative of sine of x is cosine of x. They're differentiable. But I don't get infinity over infinity. I get eternally confused between negative 1. Doesn't work. Now what they said is they were like, you know what? Since sine is stuck between 1 and negative 1, you can actually say, hey, what's the limit as you go to infinity of this guy? Well, bottom wins, 0. And how about this guy? Bottom wins, 0. Well, guess what this poor little squeezed in between guy is going to be? 0 also. There's that snazzy squeeze theorem that lets us say, sine's doing this weird squeeze thing. Yeah, it is. So therefore, at both of the ends, both of the pieces of bread that the sandwich or the middle is in between, is squeezed in between. If both are going to 0, then that guy's going to 0 also. But another way of thinking about it is that the bottom wins. Anyway, sorry guys that use L'Hopital's, but I'm kind of not sorry because that is a common mistake to see a nasty and be like, L'Hopital's, and not realize, wasn't legal to use. Then you guys have number 58. Let me give you a second. That was an infinity minus infinity one. We did do in class yesterday common denominators, didn't we? So this one was a denominator, I think, because you have two different fractions, both of them going to infinities because both of them, as you approach 2, you get number over 0. And number over 0 is that infinite form. Number over 0 is that infinite form. So you do get infinity minus infinity. But then if you get common denominators, then we get one of those nice forms that we do like. One of those nice forms that we do like. This one ends up being, I think, yeah, you end up getting 0 over 0. They didn't explicitly show it. You can see your derivative right at the bottom. And then plug and chug. And on the bottom, guys, the whole graph thing is not the important part. That's not necessarily where I want you guys to necessarily stress out or focus on, etc., etc. I want you guys instead to focus on you can do that algebraic work. Those were the evens, but you might still have some questions on the odds. So what do we have, kiddos? Anything that you guys want to see on the odds? Yeah, go ahead. Rebecca, you have one, right? What's up, kiddo? Which one? 27. Let me open up to page 511. Anything else besides number 27? Yeah. Which one? 51. Ruth? 13. Let's start at number 13 then. And then we'll work our way up. So number 13, this was past the section of, past the table, past the section of try it both ways. And this was the nope, it needs L'Hopital's. Now, guys, could you do this an old-fashioned way? Uh-oh, that's going to be a little nasty. Hold on. There's a square root. You plug in and get 0 over 0. How would we have, did anybody actually review this? How would we have done this the old-fashioned way? There was actually a test problem similar to this way back in chapter 2. Or chapter 1, I should say. Yeah, good. Multiply by the conjugate. There is an old-fashioned way of doing this. And for some of you, the old-fashioned way of multiplying by the conjugate of 25 minus x squared plus 5, 25 minus x squared plus 5, might be easier. It might be. But the L'Hopital way would say, you know what, when you plug in 0 over 0, L'Hopital's, if you're better at derivatives, it's kind of easier just to derive the square root of u over the derivative of 1, well, of x, which is 1. So up here, the derivative of minus 5 is just 0. We just need to derive the square root of u, which is 1 over 2 square root of u. So you would want to think about this guy rewritten as 25 minus x squared to the 1/2. So bring down the 1/2, this guy to the negative 1/2 power, but don't you dare kill a... Yeah, which one though? Bring down the 1/2, negative 1/2 times u prime. Scares me how long it took. Anyway, plugging in. Does it work now? What's negative 0 all over square root of 25 minus 0? Ha ha. Dun, 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 dun. Does that make sense? So L'Hopital, since I have 0 over 0, I can go ahead and take the derivative of the top and take the derivative of the bottom. And then try to plug in again. 0. You guys agree? Cool. And then number 21, I think, was the next one in order. And then number 51. No, 27. Sorry, was it 27? Yeah. 27's up here. He is a video-y one, but he is kind of a weird one. My question is, do you love yourself? When I plug in infinity, e to the infinity, think about him. Whoosh, goes to infinity. L'Hopital's. This one, there's no way to do that old school fashion style, whatever, old school technique. So I can do 3x squared over, how do I take the derivative of, maybe just a few of you would want to rewrite him as e to the 1/2 x. What's the rule for e to the u? Good, e to the u times u prime. Plug in. Aww. What do you still get? So what are you still going to do? But do you see how this guy's going down? The next one's going to be a 6. Take the derivative of e to the u, and it's e to the u times u prime. I can do it again, right? E to the u times u prime will just give me another 1/2 power. But here's the long story short. Guys, why am I going to put an equals and put a 0 at this point? There's no more infinity over infinity because the 6 does not go to infinity like the other one x's did. So who won in the long run? Bottom. Bottom one. Last but not least, number 51. Also a video. Oh! It looks awfully similar, but what's different? You're going to 0 instead of going to infinity. But here's a cool thing of limits, and maybe this is a little bit too advanced right now. I can rewrite this as the limit as from a limit property that we didn't really spend a lot of time on. I can go to positive infinity and flip everything. I know that's mean. but I can. Because going to 0 is the same thing as going to 1 over infinity, 0. And going to 1 over 0 infinity is the same thing as, oh, that's nasty. Yeah, I know. It actually does end up being e. But the way you guys would need to do it up here is super similar in the sense of proving it and not just having a cool limit property memorized like I do. You could actually do y equals, and then why would you take ln on both sides? To bring him down. But you would have to bring him down once you have an ln, and that's ln of a limit. And so you'd have ln of a limit over here. And eventually it would work out. It would just take a little bit of time. And you'd have to change that whole multiplication-y thing to division by a fraction. Now, guys, let's talk. Man, we had more questions than I thought, but that's okay. The examples took a little longer than I thought also. We have a quest on Monday on only 3 sections. And it's basically showing me you can do them. So that isn't super tricky. It's not even, it's 1 page front and back. I'm going to put up a review in Google Classroom of problems that you can practice with. Maybe I'll find some practice multiple choice too. But it's not something where you need to prepare for it like you would a normal test. You just need to know, can I do 3-6, 3-7, and 7-7? Does that make sense? Think of it as a big quiz instead of a test, and that might help you a little bit. But do you need to have L'Hôpital's card memorized? Yes. All right, get out of here, cool kids. See you later. If you have an opinion on the designs, check it out really quickly, period 6. They are very, very, very interested. So we will take your input when we talk about it today. Bye, guys.
Do you have the tests yet or no?
I have them all done. I haven't gotten the final scores. You guys will get them Monday unless you come asking for it after school today. Yeah. See ya.